Hi, this is Charles Kaplan again, professor at the State University of New York at Old Westbury, and this video shows calculus students how to do the quotient rule. I know students think of this as being incredibly, well, I want to say difficult, but I think that the better word is intimidating, and it really isn't, as you'll see as we work through these videos. This is the second video on the quotient rule. The first video worked out some easier problems, and if you haven't seen that one yet, you may want to take a look at that one first. In the meantime, this one has some more difficult problems on it, and well, I think before I actually work the problem, if you've seen this in the first video, you can skip through it and just get to, fast forward to the problem. But we have a quotient, f of x over g of x, and if we want to differentiate this, the quotient rule says we take the derivative of the numerator, f prime x, and we multiply it by the denominator, g of x, and then we subtract off the derivative of the denominator, g prime x, times the numerator, and we divide it by the denominator squared, g of x squared. And as I mentioned in the first video, I have a student who came up with this, a different notation. She said it's the derivative of the numerator times the denominator, n prime times d, minus the derivative of the denominator times the numerator, and divided by the denominator squared. And I thought that was much better notation. I think it's a lot easier. It was clever on her part, and she deserves some credit for that. Okay, so let's get right to a problem. Let's see. We've got y equals x squared plus 2 divided by x to the fourth minus 3x squared plus 1. And I don't think the paper is wide enough for this, but let's give it our best shot. I'll write a little bit smaller. Y prime, well, it's the derivative of the numerator, so it's going to be 2x times the denominator, which is x to the fourth minus 3x squared plus 1, minus the derivative of the derivative of the denominator, which is 4x cubed minus 6x, times the numerator, which is x squared plus 2. Look at that, I got it all in one line. Divided by the denominator squared. Okay, x to the fourth minus 3x squared plus 1. Okay. Now let's do our algebra. Then the algebraic workouts, tend to be the most difficult part of calculus, not the calculus rules. They're easy. So y prime is equal to, well, we have 2x to the fifth minus 6x cubed, 2x. Let's FOIL this out.
Minus, and let's whoops, put a little minus sign in here. 4x cubed times x squared is 4. 2 times 4x cubed is plus 8x cubed minus 6x cubed minus 12x, all over the denominator squared, x to the fourth minus 3x squared plus 1. Whoop! Forgot to put the square up there. Okay, so y prime, let's lift the parentheses on this step. And over here, I'm going to combine these two cubes. So 8x cubed minus 6x cubed is 2x cubed. Should I do that? No, I don't think I'm going to do that, because we're going to just, on the next step, we're going to take out these 6x cubed. Okay. 2x to the fifth minus 6x cubed plus 2x minus 4x to the fifth minus 8x cubed plus 6x cubed plus 12x. Okay, remember we had a minus sign here, so minus 4x to the fifth, minus 8x cubed, minus and a minus, plus 6x cubed, minus and a minus, plus 12x, divided by the denominator squared. Okay, let's do our combining of like terms here. We have 2x to the fifth minus 4x to the fifth is minus 2x to the fifth. No fourth degree. So the minus 6x cubed and the plus 6x cubed, they go out and we're left with minus 8x cubed. And 2x and 12x are 14x. And that's all divided by x to the fourth minus 3x squared plus 1 squared. Well, I think, this is, I think, perfectly acceptable for a derivative. However, you know, there's always that but. However, a sophisticated but. A sophisticated but is however. How's that? However, we can factor in the numerator, so let's do that. So let me move that up here. Let's put some paper down here. Okay. Well, we can factor out a 2x from the numerator. So let's do that. 2x times, well, negative x to the fourth minus 4x squared plus 7 divided by x to the fourth minus 3x squared plus 1 squared. So that little factorization, I don't think it adds a whole heck of a lot to the problem, but you never know. And if you're using it in conjunction with some other work that you're doing, rather than just differentiating a function for the exercise of it, it may come in handy. You may need it. It may make life better for you. So I would say this is an A and this is an A+. How's that sound? A, perfectly fine. Let's move on to the next problem. X squared over 1 plus the square root of x. You know, this thing looks simple, but it's going to take a little time. So I'm going to put this one aside, save it for the third video, and let's do this one, and let's end on this particular problem, because this one before it, this problem, it's going to take a little bit, and there's an extra section to this that I want to show you, and so I'm going to need most of my time for that. So let's work out this problem here. Well, square root of 10, it's just a number like 5 or 12. Square root of 10. It's just a constant. So let's rewrite this as the square root of 10 times x to the negative 6. Right? This negative exponent just says, hey, I belong in the denominator. So, okay, now it just becomes a regular power rule problem. H prime x, the derivative, is equal to negative 6 times the square root of 10 times x to the negative 7. Now we can kick this back down into the denominator. And we'll do that. We have in the numerator negative 6 times the square root of 10 times x to the 7th. And there you have it. It's a simple little problem.
Okay, so again, I'm Charles Kaplan. I hope you found this video helpful. I'll have that other problem coming up on the third video, and I have about 4 or 5 more I'll be making. And I wish you all a lot of happiness, good health, long lives, and lots of good luck along the way. Bye-bye.